Hello my dear students. Now we are going to start with the chapter of physics of class 10. Name of the chapter is chapter electricity. So we are going to deal with the most important part of the physics in this chapter. Electricity. The name itself tells the meaning of the electricity. But first of all, if we talk about electricity is of two types: static electricity and current electricity. In the syllabus of class 10th, as per CBSE board, you all have to read about current electricity. But we'll surely do the introduction of static electricity so that we should know about it. As you might have already read in class 8th about the static electricity, the word static means at rest. Electricity means something which is dealing with the charges. So when we are talking about the two substances, say I have two rods with me, rod A and rod B. Rod A and rod B. These two rods are non-living things, as all the non-living things are made up of the small particles which are known as atoms. If I make a rough diagram of atom, then in the center of the atom there is a nucleus. In the nucleus there are protons and neutrons, and outside the atom there are electrons revolving around it. Electrons have negative charge, protons have positive charge. So this rod also have protons and electrons and neutrons, and same as with this rod, B rod. Now whenever we will rub these rods, some of the charges will move from one rod to the another for in a short duration of the time. Due to this movement of the charges from one rod to the another, one rod will have access, and only one type of charges will move, that are electrons, because they are revolving outside the atom. Whereas protons are positively charges which are bound inside the nucleus, which can never come out of the nucleus unless and until there is a very much force exerting on the nucleus. So only the free particles to move are the electrons. So after rubbing these electrons, there will be movement of some electrons from one rod to the another. In this way, one rod will get excess of electrons. Say rod A got excess of electrons, so rod A will become negatively charged, and rod B got deficit of electrons, so it will become positively charged. Deficiency of electrons will get positively charged, and excess of electrons will get negatively charged. Due to this appearance of the charges on both the rods, they will get attracted to some other charged particles. But now these charges will remain at these rods. That's why we will say these rods got electrically, or these rods get electrified for some times, and the type of electricity gained by this type of rods is static electricity. Only this much introduction you need to be learned in the class 10th, but more we will read about the current electricity. Now let us start about the main topic of the class 10, that is current electricity. Now as we have read, static means at rest, whereas current deals with something which are at some motion, the moving objects, and electricity deals with the charges. Suppose again, now I will take the example of a rod, a non-living object. Now, and this time I am taking only one rod. Suppose this is made up of copper, a metal which is also known as good conductor of electricity. Good conductor of electricity. Now we all know that this will also be made up of many atoms in it, millions and millions of atoms in it. Atom again like this, inside the nucleus proton and neutron, and outside the nucleus there will be electrons revolving around it. Let me make the atom in a way as such. I will represent the atom in this way. Why? This will represent the nucleus, which have the positive charges of protons, and neutrons, which have neutral, which don't have any type of charge. And outside the nucleus there will be electrons. So I will be making the atoms in such a way. Let me draw some atoms of this rod to clarify the concept. So I have made some of the atoms of this copper rod. Now we have taken the example of a copper rod to understand the concept of the current electricity. I have taken the copper rod over here. As we know, copper rod is a metal. Copper is a metal which is also a very good conductor of electricity. Now for the representation of an atom, I have represented the atom in such a way. Why I have made in such a way? This circle will represent the nucleus, which will have protons and neutrons. Protons are only positively charged particles inside the nucleus, because neutrons are neutral. Now outside the nucleus there are electrons, which are negatively charged particles. So I will represent the atom in such a way. Now as we know, copper rod is a metal, so it will be made up of many atoms in it. So I have drawn few atoms in this rod to understand the concept at a full. Now suppose there are two ends of the wire. For understanding the concept in the first way, I will make a hint to you. If we will apply some of the force from the end A of the wire, then this force will start knocking out the electrons of the atoms. The atoms will get energy from this force. When these electrons outside the atoms will get energy from this force, these electrons will start moving towards the other end of the wire, at the end B of the wire. When these electrons are basically the charged particles, when these charged particles will start moving from one end of the wire to the another end of the wire, this will set a current in the wire. So we will say, due to the movement of the charged particles inside the copper rod, inside any metallic rod, this will give rise to the current in the wire. So how we'll learn the definition of the current now? So what is current? In the metallic rod, in any of the metallic wire or metallic rod, when the electrons start moving from one end of the wire to the another end, this will set current in the wire. So current is due to the movement of charged particles through any surface area, or we can say per unit surface area, per unit time, will give rise to current. So if I'll make the formula of the current, the very first formula of the chapter, the current will be represented by the letter I. This is the representation of current, not the unit, representation. Instead of writing the current as CURRENT, we will write the current in a one symbol, that is I. Now if I'll represent time, it will be represented by the lowercase t, not the uppercase t. Uppercase t will represent the temperature. Now if I want to write the charge, then it will be represented by the Q, letter Q. Now to make the formula, current is due to the movement of the charged particles per unit time. This is the formula of the current, that is very first formula of the chapter. I is equals to Q by T. Next we'll learn about the units of the current. We'll deal with the SI units. Unit of current, which is represented by the symbol I, is ampere. Current is always measured in amperes. Then charge, represented by letter Q, is always measured in the unit coulomb, represented by capital C or uppercase C. Then time is represented in the SI system in the seconds, or simple S you can say. So putting these units in the formula, we'll get I is equals to Q by T. Therefore I have the units ampere, 1 ampere say, charge 1 coulomb, time 1 second. So 1 ampere is equals to 1 coulomb per second. These are the SI units of the current.